The title on my slide is What Do We Know About Monkeypox and Its Risks in Water and Wastewater? As was already stated, I'm associated with the Waterborne Infectious Disease Outbreak Committee of Water Environment Federation, and I'm a research professor at the University of North Carolina. I'm no longer a full professor. I retired. What we want to do is consider this monkeypox from the standpoint of water professionals, people in the water and wastewater field. And what we know is that this virus, which has been around for a while, reemerged in something of a new form in terms of what countries are affected earlier this year. And many more countries had infected people in Europe and the Americas, in the Middle East, and more or less around the world. And many new cases showed up, even though this virus was well known and had been discovered back in the 1950s, but it was primarily based in Africa. And it has now become a worldwide concern. And that's why we want to focus on it today, because now potentially more people could be at risk in other countries. And of course, whenever a new pathogen appears that is of health concern, one of the first questions that gets asked is, what is its presence in water and wastewater, and is exposure from water, wastewater, fecal sludge, those sorts of wastes a concern? So this is an enveloped virus. It's a large envelope virus. At the bottom of the screen, you can see on the left its internal structures. We won't go into the detail about them, but it's a large brick-shaped virus, as seen from the two electron photomicrographs on the right, different versions of the same virus. It's relatively large. It's about a couple of nanometers in size, depending upon the direction in which you measure it, because it's a rectangular shaped virus. And our group has been interested in trying to understand its significance in water and wastewater. So on the next slide, you'll see some basic facts about this virus. It's endemic, as I said, in Central and West Africa, but it has now spread worldwide. And I previously mentioned that it was discovered in 1958. And it's a zoonotic virus, which means that animals harbor it. The exact host for it in the environment is still not clear, but it's probably some kind of squirrel or rodent. But that is not clear at this point, although it does infect many other kinds of animals, different squirrels and even monkeys. The good news is that this virus, which is related to smallpox virus, which has been eradicated as of 1980, the smallpox vaccine, which is still globally available, is protective against this virus. And that's good news because, well, old people like me were immunized against this virus. Younger people have not been immunized, but at least there's a vaccine available if this virus begins to spread more quickly. So what do we know about the transmission of this virus? It's spread mostly from direct skin-to-skin contact, from body fluids in the lesions that appear on the skin, which we'll show pictures of in a bit. It's in the pustules and lesions that appear on the skin, and it's also possible that you can get exposed from contaminated surfaces, fomites, such as bedding materials, towels and such, that also come in contact with the virus. And it can also be spread by respiratory contact, that is from material emanated in coughs and sneezes and such, but only from close by contact. It's also possible that it could come from infected animals, as I said, infected rodents, and the ones that are of most concern, of course, are in Africa, which is where the virus resides, but it could affect other animals. Somewhat rare and infrequent exposure might occur from airborne transmission over longer distances, but that's not very common. And at this point, there's no evidence that this is transmitted by wastewater or water or human fecal waste. So those are unproven routes of transmission, but we are concerned about it because as this virus has appeared in new places, it could be a concern to the water wastewater industry. So what we know is that it's also potentially asymptomatic, which means some people might be harboring it, but not be apparently infected. And what we know is that it primarily is for transmission occurring by direct intimate contact, including lately sexual contact. And most of the cases that have occurred recently this year have been from direct sexual contact, primarily from men having sex with men. So the virus causes these characteristic skin lesions. When you get exposed to the virus, the incubation period is typically about a week to a week and a half. But the symptoms that appear first are fever, muscle aches, fatigue, headache, and then finally the rash appears later. And once the rash appears, then that's when you become infectious. And the infection can last for 2 to 4 weeks, occasionally longer. And the rash tends to spread from the upper part of the body down to the characteristically the arms and hands. And it's these lesions that appear on the skin that are of great concern because that's where the virus is located in high concentration. And the recent outbreak underscores the importance of trying to understand what the risks are from this virus and how we can protect ourselves from it. But what we know is that because this is a zoonotic disease that could come from animals, we have to be worried about exposures to not only infected humans, especially when they're in this form of showing the lesions, but also from the rodents that could also be infected. So we're interested in the properties of the virus relative to its persistence in the environment and to disinfection, and what kind of risks it might pose to wastewater professionals. So like other large envelope viruses that have this outer layer of lipid material, it's expected to be less resistant than the typical viruses found in water and wastewater, which are the non-envelope viruses. Those are more persistent than this virus, and therefore it can be more readily inactivated by common disinfectants, such as alcohols and by chlorine, free chlorine especially, and by quaternary ammonium compounds. So it is relatively possible to control this virus with these chemical agents, especially on non-porous surfaces. The current wastewater and drinking water treatment processes that we use are expected to be protective because the relative persistence of this virus is less than many of the other pathogens that we're concerned about in water and wastewater. However, it's recommended that workers always, especially wastewater field, always take important personal protective equipment precautions around wastewater as a general rule and general practice, and that if we take those precautions, we're going to be protected from this virus and the many other viruses and other pathogens that are potentially present in wastewater, fecal wastes, and contaminated waters. And as a special concern, whenever a new virus starts to spread globally, we should make sure that if we're connected to the water community and industry, that we keep in touch with local health authorities and be aware of what we know about the potential presence of the virus in communities that are served by our water wastewater facilities. Most of the concern about this virus is with these bodily fluids, such as coming from the skin or the infectious lesions that appear on the skin. And what we know is that these contain the infectious virus, but we can kill the virus with laundering and with heat processes, such as laundering clothes, etc., bedding material, and that should prevent further spread of infection, even within households. So those are the usual kinds of infection protection and control precautions that are taken. Other information relevant to water and wastewater professionals is that it is shed, this virus, in animal feces and possibly in human feces, but the virus has actually never been detected in human feces. It's been detected in feces from monkeys and other animals, but the infectious virus has never been detected in human fecal matter, although it is potentially present in human urine, because smallpox virus, to which this is related, was shown to be present in human urine. To date, infectious monkeypox virus has not been detected in water or wastewater, nor has its nucleic acid, its DNA or genetic material. The likelihood is that the DNA might be detectable in water and wastewater, but that has not been shown yet. There are other viruses that we can detect by detecting their nucleic acid in water and wastewater, but we have not even done that yet for this virus, and it's very unlikely that this virus will be present in an infectious form in water, wastewater, fecal sludge, and so on. What we have to do as wastewater professionals is maybe add this virus to the list of pathogens, such as SARS-CoV-2, the virus that causes COVID-19 disease, by wastewater monitoring, so-called wastewater-based epidemiology. I guess there are considerations of that. Maybe this virus may be added to the list of those that are currently being looked for. But at this time, the bottom line is that this is a low risk to humans from human waste exposures, such as from sewage, fecal sludge, biosolids, or various waters.
Yeah. Thank you for your comments and presentation.
So that's just a quick overview. And the information that I've just presented is mostly from the fact sheet that was produced by the WIDUC group and is available from the Water Environment Federation. If you're a member of the Federation, you should be able to get it because it appeared in a newsletter just a week or two ago. But if you have trouble finding the fact sheet, you can always contact me and I can send it to you, because it should be widely distributed to those in the wastewater community.
Thank you, Professor. We'll not have time for more questions, but this will be published. It's a lot of contents. I learned a lot on this in this presentation, but I will have to review it slowly and read through all the documents. So thank you very much.
People are always welcome to contact me if they want more information. I'm happy to help those who have concerns about this virus.
Definitely. Thank you very much. Thanks.
You're welcome.